See, reaction involving the cleavage of the carbon-oxygen bond. So the bond break is happening between the carbon and oxygen. So that means the bond is breaking between here and here. Okay. So there are three different reactions we can see here. One is the reaction with the HX. So next one, the reaction with the PX3, and there is a dehydration reaction. That means you will be removing the water molecule in this reaction. So that's why it is called as the dehydration reaction. Okay. So we'll be seeing all these three reactions today. So the first one, the reaction with the hydrogen halide. Okay, so what does this reaction? When an alcohol reacts with a hydrogen halide, there is a substitution takes place, producing an alkyl halide and the water. For suppose you see the reaction, there is a alcohol. When it is reacting with the hydrogen halide, it will give alkyl halide, that is RX, and it will give water molecule, that is H2O. So what are you saying here? When an alcohol reacts with the hydrogen halides, when it reacts with the hydrogen halides, that is HX, there is a substitution takes place here. What is substituting here? R is breaking the bond and X is going and attaching here. So there's a substitution is happening here. So which result in formation of the alkyl halides and water. So this is the reaction with the hydrogen halides. Okay. And if you see the order of the reaction, the tertiary alcohols will show more reactivity than the secondary alcohols than the primary alcohols. The order of the reaction is very, very important. So if it is tertiary alcohol, it will be more reactive compared to the secondary alcohol, compared to the primary alcohol. Remember this, there is some questions are there, I'll ask you. Okay, so the order of reactivity for the alcohol is tertiary is greater than secondary is greater than primary, or more reactivity than the other. Is it clear up to here?
Yes, sir.
So that is for the order of reactivity of the alcohol. Then what about the order of reactivity of HX? In this, hydrogen iodide is more reactive than hydrogen bromide is more reactive than hydrogen chloride. Okay, because hydrogen iodide is a bigger molecule and bromide is smaller and chloride is much more smaller. And if you see the hydrogen fluoride is unreactive. So just remember this. So it is unreactive. Hydrogen fluoride is unreactive. Understood? So if you see the carbon, tertiary alcohols greater than secondary alcohols greater than primary alcohol. If you see the halides, hydrogen iodide is greater reactive than the bromide than the hydrogen chloride. Okay, so why? The reactivity of the halogen acids, that means HF, HCl, HBr, HI, it is explained based of bond dissociation energy. Okay, so what is meaning of bond dissociation? So for suppose there is a hydrogen is there, iodine is there, they have a bond between them. So what kind of bond is present here? Some kind of covalent bond, okay, is present here. So when you break the bond between them, so one will be turning into positive, one will be turning into negative. Okay, so iodine will turn into negative, hydrogen will turn into positive. So this cleavage is called as the bond dissociation, and the energy required to break the bond between the hydrogen and iodine, it is called as the bond dissociation energy. So what is meaning of bond dissociation energy? The amount of energy required to break the bond between the hydrogen and iodine is called as bond dissociation energy. So for iodine iodide, it requires very least amount of energy compared to the hydrogen chloride. And hydrogen fluoride, it is very unreactive because hydrogen and fluoride are very hardly bound. So you cannot separate them. You can easily separate the hydrogen and iodine. You can somewhat separate the bromine. It takes some hard for chlorine to separate, but fluorine, you cannot do that. So that's why it is generally unreactive. Is it clear?
Yes, sir.
So test for alcohols. For suppose if I have given you some compound and you don't know what is that compound, in order to test that, so we'll be doing some series of tests. So one such test is the alcohol test. Whether the compound is alcohol or not, you will be testing it. So that will be done by the Lucas test. So why does the name Lucas came here? See, Lucas test is because we are using a reagent. That reagent name is called the Lucas reagent. So it got its name because of the Lucas reagent. And what is that Lucas reagent? It is nothing but the concentrated HCl and anhydrous zinc chloride. So this mixture, we call it as the Lucas reagent. And we are we are doing this test using this Lucas reagent. So it's called the Lucas test. So primary, secondary, tertiary alcohols can be determined by taking the advantage of the relative rates. Okay, so how we are differentiating here? So we are doing the alcohol test. In that, there is a primary alcohol is there, secondary alcohol is there, tertiary alcohol is there. But how can you differentiate whether this is a primary alcohol or secondary alcohol or tertiary alcohol? On what means you will be determining? So that is based on the relative rates. Okay. So based on what rate at which the reaction can happen. So based on that, you can separate them. Understood? For suppose here, the tertiary will instantly react compared to the secondary, compared to the primary. So based on that, we will be differentiating between the primary alcohol, secondary alcohol, and tertiary alcohol. Is it clear how we are doing this? So just remember, tertiary is more reactive than secondary than primary. We know that. So the reaction can easily happen, immediately will happen for tertiary compared to the secondary, compared to the primary. So based on that advantage, we can able to determine three classes of alcohol react with concentration HCl and zinc chloride. So when you react with HCl and zinc chloride, so one will show very immediate reaction, the other will show somewhat good reaction, the other one will take time. So based on that, you will be differentiating whether this is tertiary alcohol or secondary alcohol or primary alcohol. Understood? How we will be differentiating the primary, secondary, and tertiary using the Lucas test.
Yes, sir.
And just remember, what is Lucas reagent? It is nothing but the concentrated hydrochloric acid and anhydrous zinc chloride. Okay. So the Lucas reagent gives a white turbidity or cloudiness with alcohol. So turbidity, it gives like a white, thick, fluid-like thing. Or you can say like when the milk is evaporating, it will give some thick fluid on the top surface. The same kind of thing you will see here. So there will be white turbidity or cloudiness will show when it reacts with the alcohol. Okay. And we know whatever the functional group OH is there, it is attached by the covalent bond. And what kind of covalent bond? sp3 hybridized covalent bond. So just remember this. Okay. So what happens? The reaction will go in this way. So you take ROH. This ROH reacts with concentrated HCl or zinc chloride. It will give Rx plus water. Okay. So remember, so alcohol reacts with the concentrated hydrochloric acid and in the presence of anhydrous zinc chloride. And that will give alkyl halide and water. Understood? So alcohol reacts with the Lucas reagent in order to give the alkyl halides and water. And here, whatever the OH is there, it will attach to the carbon with the help of sp3 bond. Covalent bond, and that is sp3 hybridized covalent bond. Understood? So primary alcohol. So what happens for the primary alcohol? So if you see at room temperature, primary alcohol doesn't turbid or cloudy solution. So if you do at room temperature, it will not show any reaction. It will not form any halides. Okay, it will not form any alkyl halides. In order to show the reaction, you must eat it. So that eating will act like a catalyst and it will let the reaction to happen. For suppose you take uh, RCOH. So what kind of carbon is this? It is just attached to one functional group. I mean one R group, one carbon. So we call this as the primary carbon. Understood? So this is a primary carbon. And the functional group attached to the primary carbon, so we call it as the primary alcohol. This primary alcohol in presence of the Lucas reagent, that is concentrated HCl and anhydrous zinc chloride. And you must eat this reaction to happen. So you should show the eating. So there is a eating, and which will result in formation of RCHHCl. So only if you eat, the reaction will happen. If you don't eat, and if you do the reaction in the room temperature, the reaction will not show any alkyl halide. So when there is no alkyl halide, there will be no turbidity or no cloud solution. So you can justify here. If it is primary alcohol, only on presence of eating, it will show the turbidity. That you remember. Okay. So primary alcohol, only on eating will show turbidity. Understood? So next one, secondary alcohol. Here at room temperature, the reaction can happen, but it will take 5 minutes for the turbidity to show. So the same here. So you take the secondary alcohol that is attached to two carbons, two alkyl groups, and there is a OH. So upon the Lucas reagent, LR means Lucas reagent, it will show the secondary alkyl halides. But here it will take 5 minutes. So just you remember that thing. Okay. It will take 5 minutes at room temperature. So by that you can justify that it is a secondary alcohol. If it is only on the eating, if it shows the turbidity, then it's a primary alcohol. Without eating at room temperature, after 5 minutes, if it shows the turbidity, then you can say it is a secondary alcohol. And finally, tertiary alcohol that gives turbidity immediately. That means at room temperature, just by reacting, if you add the Lucas reagent into this alcohol, immediately it will show the turbidity. Immediately it will show the turbidity. Then you can say this is a tertiary alcohol. Lucas reagent. It will show. Understood? So here immediately you take the alcohol, you just add the Lucas reagent. If it immediately shows the turbidity, then you can say it is a tertiary alcohol. If it shows after 5 minutes at room temperature, then you can consider it as secondary alcohol. It is not showing even after 5 minutes. It is not showing even after 5 minutes. You should eat it, then only it shows the turbidity. Then it is called as the primary alcohol. Understood? So that's how you will be differentiating primary, secondary, tertiary alcohols by using the Lucas test, Lucas reagent. And what is primary alcohol, secondary alcohol, tertiary alcohol? If it is only having one R group or attached to only one carbon, then it is known as the primary alcohol. If it is attached to two carbons, secondary alcohol. If it is attached to three carbons, tertiary alcohol. Clear? Any doubts?
No, sir. Good.
Okay.
No, sir.
1 second, guys. Okay. So that is how we'll be doing the first reaction. Second reaction, reaction with phosphorus trihalide. Okay, so alcohols are converted into the alkyl halides by reacting with the phosphorus trihalides. For suppose you take the reaction, it will be like 3ROH, an alcohol, plus phosphorus trihalide. Upon reaction, it will give 3R X. So whatever the X3 present here, it will break the bond with the phosphorus and each X will bind to one R. So whatever the three OHs are there, each OH will be replaced with one X. So there will be ROH, ROH, ROH. And there is a PX3, P, X, X, X. Okay, so each one will break the bond. So each one will break the bond here and go and attach here. Break the bond here, go and attach here. Break the bond here, go and attach here. So like that, it will form 3RX, which is nothing but alkyl halide plus H3PO3. And whatever the OH are there, these OH will come and attach to the phosphorus. Okay, so that will form H3PO3. Understood? What is H3PO3 called as? What is the name for this?
Phosphoric acid.
Phosphorus acid. It is named as so simple. Whatever the X is there, each X will replace the OH. So the phosphorus acid will look like that. So it will look like POH, or you can write like this. This is OH. The same way there will be another OH, and there will be only one single O, and there is a hydrogen. Okay, understood? Actually, sorry, this is double bond now because oxygen needs to make a two bonds. So double bond O. So this is the phosphorus acid. Clear? So just remember.
Yes.
So just remember. So when an alcohol reacts with the phosphorus trihalides, so what is this? This is called as the phosphorus trihalide. So when you react with this phosphorus trihalide, it will give alkyl halides and phosphorus acid. Okay. You can write this example. So like 3C2H5OH, when you react with a PCl3, it will give 3C2H5Cl plus H3PO3. You can write this example. So the third one, what is the third one? So one is done, reacting with the hydrogen halides. Second one is phosphorus trihalides. What is the third way? At the beginning, I told you there is a three reagents, so three ways of reactions. What is the third one?
Dehydration.
Yeah, dehydration of alcohol. Guys, tell me honestly, how many of you are writing when I am telling the class?
Sir, I'm writing.
Nitya,
I'm writing, sir.
Sir, I'm writing, sir.
really? Send me the photos in the group.
Sir,
I'll
I'll
see.
bring the book tomorrow.
Right now, sir.
What? You will bring the book now? Arey, Srikar, Noora?
Sir, I'm not writing.
అరే నీకు బలిసిందిరా, నీకు మొన్న కూడా చెప్పాను రాయిరా క్లాస్ వింటున్నప్పుడు అని.
So for today, leave me, sir. I'll write from tomorrow.
బద్ధకం ఎక్కువైపోయిందిరా నీకు బాగా.
Sir, what about the come sir? Morning में class వెంట కలిసి అది అనిపించారు.
సరేలే. గుడ్ శరణ్. నిత్య, మందారా.
Sir, I sent now, sir.
Yes, sir. I'm sending 1 minute.
ఓకే ఓకే గుడ్. ఓకే గైస్, మందారా యూ సెండ్, ఐల్ చెక్. Mandara, you are writing now and sending the photo?
Sir, my sister's phone, so she was using it. I had to get it from her.
Okay, leave it. Send me later. So next one. The third way is dehydration of alcohols. So how do we do that? So dehydration requires an acid catalyst here. So in this reaction, we will be using the acid catalyst to protonate the hydroxyl group of the alcohol and convert it to good living group. If you remember in the previous class, I told you. So whenever it is attached like this, ROH, here the OH is not a very good living group. Yes or no? In the previous class, I told you the OH is a very bad living group. So we cannot break it easily. So in order to make it a good living group, we need to protonate it. So what is this? ROH, remember, it is a bad living group. In order to make it a good living group, we need to protonate it. That means we need to add the proton. So when we add the proton, ROH, and you add proton to the oxygen, it will become positive charge. So now this is a very good living group. So this will break the bond here and it will leave out. So that will turn out to be R positive and water molecule. So remember, the OH is a very bad living group and here H2O is a very good living group. And how it is happening? How the conversion of the bad living group into the good living group is happening because of a proton. So the proton plays a very key role here. So remember, the proton plays very important role. So see here, dehydration require an acid catalyst. So here, in order to make it a bad living group to the good living group, you need a proton. So that the proton will go and attach to the oxygen so that it will form the water molecule and that will act like a good living group. But who will guys, am I audible?
So your voice is breaking.
Is it breaking from the before or is it breaking now?
Right now.
Am I audible?
Yes, sir.
Okay. Is it clear or is it breaking for still?
Clear, sir.
Now
Okay. Okay. So see here, ROH, it is a very bad living group. We are converting this bad living group into the good living group with the help of a proton. But where do you get this proton? This proton you will get from the acid catalyst. There will be some reagents you will be using. Those reagents will supply the protons. Okay, so when the proton is supplied, whatever the OH is there, it will convert into the water molecule and it will leave off. So as the water molecule is leaving here, so that is why it is called as the dehydration of alcohols. Okay, the loss of water followed by the loss of proton gives the alkene. See here. So once the water is lost, now it will become positively charged carbon. Now this positively charged carbon, you should also leave the proton here. You should leave the positive charge here. And from that, it will make a double bond. As it is making the double bond, it is called the alkene. Understood? So how this reaction is happening, you understood? It will happen in two ways. So one is first the proton. Okay, it will happen in three ways. First, you need to add the proton. Once the proton is added, it will turn out to be a good living group. So this good living group will leave. So that is the second thing. And the third thing is, so once the water molecule is left, now it will turn into a positive charge. This positive charge will also be removed by double bond, by making the double bond. So by forming the alkene here. So that's the third. So this is called the dehydration of alcohols. Any doubts how this mechanism is happening? So just remember here, one thing you remember. So what are the reagents we will use here that acts like acid catalyst? So what are the reagents that we use here that acts like a acid catalyst? The reagents are, one will be S3PO4, and you should eat it for the reaction to happen. And the second one is concentrated sulfuric acid, S2SO4. It is a concentrated one. And here also you need to eat it. Okay, so these are the two reagents we'll be using. One is the S3PO4, the other one is concentrated sulfuric acid. Okay, so just remember this. These are the two reagents. So why we are using these reagents? In order to get the proton. Why do we need the proton? To convert the bad living group into the good living group. So once the bad living group is converted into the good living group, the water molecule will be eliminated. Once the water molecule is eliminated, so that is why it is called the dehydration. After that, there is a formation of the double bond. So alkene will be formed. Okay. So just see here, you take a general reaction will look like this. So there's a carbon which is having hydrogen, and there's a hydrogen. And there's a carbon, hydrogen, and OH. In the presence of the acid, which acts like proton supplier. So the reaction will turn out to be like this. Plus water molecule. So what happening here? The OH will be removed. So once the OH is removed, it will be creating the positive charge here. So once the positive charge is cleared, you will also remove one hydrogen here or from here. Okay. So once the hydrogen is removed from here, they both will make the double bond. So this reaction will happen like this. So one is CH3, CH2. So it will turn out to be the positive charge. And here one hydrogen you will be removing. So that will turn out to be, so remove one hydrogen from here. So that will turn out to be CH2 double bond CH2. So that's how from this you are getting an alkene. Understood? So just remember this. So this is the dehydration reaction of alcohol, because at the end you are getting the water as you are removing the water from the alcohol. So it is called as the dehydration of alcohols. So this mechanism involves three ways and it will follow the E1 mechanism. If you remember, we have discussed E1 mechanism. So step one, the protonation of the alcohol. Step two, am I audible? It's your, am I audible?
Yes.
Am I audible?
Yes,
Yes,
sir.
sir.
Okay. So see here, this involves the three mechanism. Okay, sorry, three steps. One is the protonation of the alcohol, the formation of the carbocation, and there is a deprotonation. Okay. So there's the third one is the deprotonation. So what is the protonation of the alcohol? So let's see step one. Protonation of alcohol. This reaction will go like this. So there's a CH3, C, CH3. So which alcohol is this? Primary or secondary or tertiary?
Tertiary.
Tertiary. Okay. So first one, what we need to do? We need to do the protonation of alcohol. Okay. So how we have to do? We need to attach some hydrogen here. Okay. So there is a lone pair of electrons are present on the oxygen. These lone pair of electrons will try to give the electrons to someone. So they will call the hydrogen. Hey, hydrogen, you come here. I'll give you the electrons to you. So the poor hydrogen will come to that fellow. For suppose, let's take another one. Hydrogen. O. So let's take OH3. Okay. So what's happening here? Now, whatever the this oxygen is there, it will try to take out its lone pair of electrons from this hydrogen. Okay. So when it try to pull out its hydrogen, its electron from this hydrogen, now this hydrogen will not have any electrons in it. So there's no electrons at all. Why? Because whatever the electrons that involved in the bonding, that is taken by this oxygen. So now this proton doesn't have any electrons. It is zero electron. Hydrogen, we know it's only having one electron. That electron is also lost here. So this guy doesn't have any electrons, so it is called as the proton, because protons are nothing but the positive charge without any electrons. So now this proton will come and approach this oxygen, because this oxygen is calling this guy. I have an extra electrons, you come here, I'll give you. So this guy will go there and he will attach here. Okay. So he will try to bind here. So that result in CS3, CS3, CH3. So that hydrogen will come and bind here. So as there is a two extra hydrogens are attached and the oxygen is having the three bonds, so it will be positive charge. Okay, so that's what it's called, the protonation of alcohol. How does it happen? A proton come and bind to the oxygen. Now there will be creation of the positive charge because oxygen can only carry two bonds. But if you see here, one, two, three, there are three bonds are there. One extra bond is there. So it is also very unstable because we know this is a very good living group. So it want to leave. So there is a bond breakage will happen here. So there will be bond breakage will happen here. Okay. And whatever this one is there, it will be the water molecule. Understood? So this is the step one, the protonation of alcohols. Is it clear? How does the protonation of alcohol happen?
Sir, could you repeat like a summary?
So what happened here? There is an alcohol. This is a tertiary alcohol. Okay. So this tertiary alcohol is having the oxygen and hydrogen. Here the oxygen is having the lone pair of electrons. Okay. And there is some acid. Okay. Leave about this. Just remember here, there's a OH3. Now this OH3 want to break the bond with the hydrogen. Why? Because here it's a very unstable because oxygen can only bond with the two atoms, but here it's a three atoms. Okay,
Sir, the voice
so
is back in the
my
middle.
voice is lagging.
Yes, sir, in the middle.
Actually, there's a due to weather or I don't know, but the internet is lagging. Hmm, is it still lagging? Hmm,
So when you talk lag,
so tell me, is it still lagging?
it's okay, sir.
So see here, what's happening here? So there is an alcohol. This alcohol contain the oxygen and hydrogen. This oxygen, your internet connection is unstable.
So internet is not good, I guess.
Yeah. Actually, there's a issue today, I think. 1 second, I'll try to connect with my mobile. So how about now?
Yes, sir, okay, sir.
Is it okay?
Yes, sir.
Okay. So see here. So there is a alcohol which is having the oxygen and hydrogen. So this alcohol containing the oxygen which has the two lone pairs here. Okay. And there is a what? There's a this S3O. Okay. So this S3O is formed from the acid. Just now you remember there's a S3O. And this S3O is breaking the bond with the hydrogen. And whatever the bond having the electrons, it is taken by the oxygen. Okay. So first the oxygen will break the bond with the hydrogen and it will take away the electrons with it. So now this poor guy doesn't have any electrons. He become like a proton. Now this proton will approach the oxygen because it is containing the two lone pair of electrons. The oxygen will give this guy so that he will come here. Okay. So that's how there is a formation of the good living group. So that's a step number one. Understood? The protonation of the alcohols.
Yes, sir.
So now the step number two, formation of carbocation. So how does this will happen? This will happen like this. So again, now you take this CS3, CH3, CH3. So there's a proton will come and attach to the water molecule. So this will become a good living group. So as it is a good living group, this guy will break the bond here and he will leave. So there will be a bond breakers will happen between the water molecule and the alkyl group. So that result in C positive, CH3, 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 and there is a water molecule. Understood? So this guy has broken the bond, and here because of that, you will be having the positive charge. Okay, so that's a formation of carbocation. You understood why it got the name carbocation? Because of this. Okay, so this is the step number 2. Now the step number 3, deprotonation. So whatever the positive charge is there on the carbon, we need to remove that positive charge. So that is what it is called as deprotonation. If you see here the carbon is having the positive charge. Removing this positive charge is called as the deprotonation. So how do we do that? So for suppose you take how is it present? There's a carbon and there is a CS3, there is a CS3 and there is a CS3. Okay, so see here, there's a carbon. There's a carbon, CH3, CH3, and whatever the up CS3 is there, I'm elaborating it. Okay, so I'll be elongating the structure. So if you see here, there is a 3 CS3, 1, 2, and 3. This structure I elongated. So whatever now this bond and this one is a positive charge. This carbon is containing the positive charge. And whatever the bond present here, this one between the carbon and hydrogen, this bond will break. Okay, so how does this bond will break? Because of the water molecule. Okay, so this water molecule is containing the lone pair of electrons. So those lone pair of electrons will ask this hydrogen to come here. Okay, will influence to come here. So this guy will break the bond and he will attach here. So once the bond is broken here, whatever the electrons present here, those electrons will move on this carbon. Okay, so this guy will break the bond and whatever the electrons are there, these electrons will go here. Okay, so why this guy will break here? Because see here, this carbon and this carbon both are very good friends. Okay, but this carbon is under a very great deficit. So this carbon should give something to this carbon. He has to help him. But this carbon already is having some other guy to help. So what he will do, he will stop helping this hydrogen. So this hydrogen will break the bond and he will go to this oxygen because as this carbon stopped helping, so this oxygen is supplying help to the hydrogen now. So this hydrogen will jump here and whatever the electrons present here, that will go to this carbon. So because of that, there is a good bond formation will happen. So C double bond C and there is a H2. So whatever this hydrogen is there, it's a CH2. And there's a CH3, CH3. And what about this? This one will form like this. Plus O hydrogen, hydrogen, hydrogen. You will be having positive charge here. Understood? So how this bond happen? So there's a cleavage will happen here. So this hydrogen will go and attach to the water molecule. And whatever the bonds that are present here, they will make a double bond between the carbon and carbon. Understood? So this is the deprotonation structure. So however the proton is present on this carbon, that will be removed by making the double bond. So it is called as deprotonation. Just remember the order of reactivity, tertiary alcohol is more than the secondary alcohol than primary alcohol for the dehydration reaction to happen. Okay. So just remember order of reactivity for dehydration reaction is tertiary is greater than secondary is greater than primary. Okay. Clear?
Yes, sir.
Yes, sir.
Yes.
So just see few examples. C2H5OH. I'm not writing the entire mechanism, so I'm just writing the reactants and products. It will form CH2 double bond CH2 plus water. So what kind of alcohol is this? C2H5OH. Is it a primary or secondary or tertiary? Come on, tell me. Yeah, it is a primary. So just write here, it's a primary. I'll tell you what important is this. Next one. So there's other one, CH3, CH, CS3, and there's a OH here. Or you can write like this. There's a OH and there's a CS3. So this OH will leave and there is a double bond happen between the two. Plus water molecule. And there's a, what kind of is this? Secondary, right? So this is a secondary alcohol. Now take the tertiary one. This is a tertiary one. So if you see here, for primary, secondary, tertiary. So which one is more reactive? Primary or secondary or tertiary?
Tertiary.
Tertiary is more reactive. So if I say who one need a more catalyst, does the primary need more catalyst or tertiary need more catalyst in order to happen the reaction?
Primary.
Primary need the catalyst, stronger catalyst compared to tertiary. And second thing, if you see the temperature, which one need more temperature in order to a reaction to happen? Primary or secondary or tertiary? Which one need high temperature in order to reaction happen? Because we know someone who is weak, they need temperature. Someone who is easily reactive, they doesn't need the temperature much. So in that case, primary need more temperature. Now see the catalysts, how they are. So for this 20% S3PO4 and 358 Kelvin. For this 85% S3PO4 at 440 Kelvin. And for this, you need 100% and stronger catalyst than this. So concentrated sulfuric acid and 443 Kelvin. So if you see the catalyst wise, it is only 20% S3PO4. So phosphorus acid, which is a very dilute one. Here, 85% concentrated one. Here, it is a much more stronger than this acid, sulfuric acid, the king of all acids, and temperature 443 Kelvin. Understood? So based
Yes.
on the rate of reaction, how the catalyst were changed. Any questions?
No, sir.
Okay.
No.
So tell me what, yeah. Nitya, tell me, you're saying something?
No, sir.
Okay. So tell me, what is the answer for this? Okay, so we know that after removing the alcohol, what happens? There will be a formation of the alkene. Yes or no? There will be formation of the double bond. But the question is whether the double bond will form here or here. Because we know here also there's a carbon, here also there's a carbon. After removal of this OH, So protonation will happen here. The positive charge will happen here. After deprotonation, the bond should either form here or it should form here. So what is the location? The bond will happen. So that is the question here. Okay. So now this will happen like this. It will form both the ways. The bond will form here as well as here. So just remember, actually this carbon is said to be B1 carbon and this is B2 carbon. Remember. So it will form two compounds. One will be this way and there's a this way. So if you see here, here the double bond will happen here and here the double bond will happen. Okay. And this is called as this is the major one and this is the minor one. Okay. Actually, the name for this one, we call it as the trans 2 butene. And this one named as but 1 ene. Okay. So just remember this is the major and this will be the minor one. So how does this will form? So there will be a removal of the beta 2 hydrogen that will result in formation of the trans 2 butene. There is a removal of the hydrogen from the beta 1 and that will result in formation of beta 1 ene. And you know, right, trans structure, cis structure. So that is why it is called as the trans 2 butene and it will prefer more compared to the but 1 ene. Okay. So just remember this one thing. So next one. Again, you have a two chances where the double bond will form. So which one will be the major product and which one will be the minor product? So whether it will form double bond here or it will form double bond here. So the question is that, okay? So when it reacts with a sulfuric acid. So when it reacts with a sulfuric acid, which one is? So it will happen like this. See, in the first condition, see, I'm not getting in detail why it is forming this major and why it is forming this minor. Just remember it, okay? So tell me which one will be the major and which one will be the minor from the previous condition, from the previous question.
First one is major, second one is minor.
Yeah, this will be the major and this will be the minor. Okay. So next one is rearrangement possible for the carbocation format? So once the water molecule, so whatever the OH is there, it will attach with the hydrogen and it will be removed. Once it is removed, what happened? It will form the carbocation. There will be positive charge created on the carbocation. So on this carbocation, can it move from one carbocation to other carbocation? Okay. For suppose you see here in the previous example. So what's happening here? There is a OH here. After leaving this OH by attaching to the hydrogen, it will remove like a water molecule. There should be formation of the positive charge over here. Now this positive charge is called as the carbocation. Can it move on to this carbon or this carbon or this carbon? So that is called as the rearrangement of carbocation. Whether is it possible or not? For suppose take an example. So there's a CH3, CS2, CS3, CS3, OH. By the protonation and removal of the water molecule, it will turn out to be CH3, CH3. As the proton will be removed from this place, as it is removed from this place, so there will be positive charge will create on this carbon. Yes or no? So there's a CH3, CS2. So the positive charge was present over this carbon. Now this will convert into so whatever this CH3 is there, now it will go and jump here. So when it will go and jump here, now this will get the positive charge. Understood? So this CH3 is there, it left. When it left, what happened? It will form like this, CH2, CH3. So there's a positive charge. And when the CH3 is left, there is a positive charge over here. But now this CH3 which is left, it will come and bind to this carbon. When it will come and bind to this carbon, whatever the positive charge present over here, it will disappear and there will be positive charge over here. So if you see the positive charge which is present over this carbon has moved to this carbon by rearrangement. Understood? So that is what this thing is. Rearrangement is possible or not. And finally, this will give like this. So CH3, C, CH3, double bond, CH, CH3. So if you see here, the double bond should be present over here in the previous condition. But due to the CH3 has moved to here, the double bond is formed here. So initially, if you see, you can consider this as a primary carbon and double bond is present on the primary carbon. Sorry, on the first carbon. But if you see here, it is now not present on the first carbon. Understood? So what is meaning of rearrangement? Is rearrangement is possible or not? So this kind of rearrangement, as the methyl has moved from the second carbon to the primary carbon, so we call this as the 1,2 methyl shift. Understood? What is meaning of 1,2 methyl shift? And what is the rearrangement is possible for the carbocation? And if the rearrangement happens, where does the double bond has moved to where? So if rearrangement doesn't happen, the double bond will form here. But due to the rearrangement, now it formed here. So instead of having on the first carbon, now it is present on the second carbon due to the shuffling of the some molecules.